Hello and welcome back to my video series on prime numbers and composite numbers. So in a previous video I showed that 1 is not prime, or I showed that 1 should not be classed as prime, and I gave arguments for that. Now I'm going to show that 1 should not be classed as composite, and I'm going to present an argument for that too. So a composite number C is any integer or whole number which has smaller divisors or factors apart from 1 and itself. So it's the opposite of a prime number, i.e. a number will be prime or composite. But wait, in another video we said 1 is not prime. So wouldn't that therefore mean it's composite? Well, you would think so, but mathematics is full of exceptions, and 1 is a very special exception. It's not in fact composite, or I am claiming it is not composite. So let's consider some small composite numbers, 4, 6, 8, 9, 10, 12, 14, 15. Let's factorize them. So there's 4, 6, 8 and 9. I've written some factors of them. I've not included 1 in the number itself because they're trivial. We want to look at other factors to show that they're composite. So these numbers are all composite because, as you can see, they are composed of factors that are not 1 or themselves. So 6 can be written as 1 times 6, but it can also be written as 2 times 3, and 2 and 3 are not equal to 1 or 6, so 6 is composite, and that works for 4, 8 and 9 as well. And there are infinitely many of these. 10 is 2 times 5, 14, 2 times 7, 15, 3 times 5. Notice 12 can be written a couple of different ways, apart from 1 in itself. It can be written as 2 times 6 or 3 times 4. So it actually has 4 divisors that are not 1 or itself. So you get the general idea. So what do all these numbers have in common? They are composed of factors. Notice the word composed. Other than 1 in themselves. So this is where composite comes from. Composite comes from composed. Numbers composed of other factors or divisors to make up the number. If it's not composed of other factors, then we call it prime. Note, every number has a factor of 1 in itself. Well, that's pretty obvious. We don't need to prove that. I'm sure you can deduce that for yourselves. So the factors of composite numbers, which are not 1 in themselves, lie strictly between 1 and themselves. Pick a number n equals 12, then for 12 to be composite, it must have a factor or divisor between 1 and 12 and not equal to 1 and 12. Let's call the factor f. So 1 is strictly less than f, which is strictly less than 12. Notice f is strictly greater than 1 and strictly less than 12. In fact, 12 has factors 2, 3, 4, 6, which are all strictly between 1 and 12. 12 equals 1 times 12, 12 equals 2 times 6, 12 equals 3 times 4. So 1 is less than, strictly less than, this set of numbers here in the curly brackets, 2, 3, 4 and 6, which is strictly less than 12. Each of those are strictly less than 12. This will hold for any composite number. However, 1 breaks this rule. For 1 to be composite, it must have a factor f not equal to 1 or itself, i.e. strictly between 1 and itself, i.e. 1 and 1, i.e. 1 is strictly less than f, strictly less than 1. Or written another way, 1 strictly less than f and 1 strictly greater than f. Hold on a minute, a number cannot be greater than 1 and less than 1 at the same time. It's got to be one or the other. So this is impossible since f must be an integer and there is no integer which is strictly bigger than 1 and strictly smaller than 1. So therefore 1 cannot be composite. I hope you enjoyed this video. Thanks for watching. Please subscribe.